This is Scott from KIG. It is March 30th, 2020. We're in our small chiller test area here in Clinton, Massachusetts. And we're going to do a quick little pull down test on this sold Advantage slash Temptek 2-ton air-cooled chiller. We have a little bit of glycol and set up a glycol loop, and we've tested this before here in the reservoir tank. And our customer needs to run this at approximately 20F. The controller itself is actually set up to go down as low as 10F. Honestly, if you want a 20F glycol temperature, I'd probably run it at 22 because there is a dead band or a differential range. But the controller is super simple. All you do is press the up and down. We'll run it down to the 20 set point. As you can see, it's already turned on. This is a 460 volt three-phase unit. In the world of chillers, honestly, I'm very close to the unit, but in the world of chillers, it's pretty damn quiet, frankly. 9.1 amps is the tag rating for load. Now this back room today is probably about 58 degrees ambient. In a hotter ambient environment, it'll draw more amps. Let's see what, I'm gonna guess it's gonna be in the 6 range or something. So always be careful when you're in a control cabinet. Right now, oh, I'm sorry, I'm on the wrong one. Yeah, that makes more sense. So, right now in this environment, compressor on, pump on, fan on, drawing about 6.1 amps. If it was 90 degrees in here, 95, I'd say it's probably going to draw about 10 or 20% more than that. Just working a little bit harder. This unit, like I said, we've tested before, but I just want to double check it go down to that lower temperature. My technician Dana adjusted the pressure switches. On the left there, that's the low. On the right, that's the high. That's a reset switch there. We do have the top cover, of course, just set off over to the side there. So all controllers have a built-in differential or hysteresis, if you want to call it. This one, I think it's about plus or I think it's minus 3 or 4 degrees plus 2. It's like a 5 or 6 degree differential, and that's normal on a chiller. Some chillers it's more like 8. So what does that mean? It means we're going to get to 20 and we're probably going to go below 20 by 2 or 3 degrees. As we get close to 20, you'll probably hear the hot gas bypass or the capacity control kick on. If you have a bigger heat load, which we don't, that hot gas bypass or capacity control will allow the compressor to run longer and slow down the speed of that decreasing temperature, if you will, like we are in just this room test environment here. But again, if you want to, and as you get closer with any chiller, as you get down to these colder temperatures, with every degree colder you get, the less capacity in BTUs per hour it has. It's like towing a car uphill. So as we get colder, the speed at which that drops decreases. Although it's still going down pretty quickly. But if you truly need 20, you want to get away with the highest temperature that you can for your process. But if you truly need 20, I'd probably set it at 22 or 23 because it's going to keep chilling until it reaches that about 3 degrees below that. So you got your water pressure gauge and your low pressure and your high pressure gauge there. The unit is a three-phase unit, so when you first do start it up, you'll want somebody to bump the contactor in the cabinet, or just turn the toggle switch while you have somebody, kind of hard to see here, somebody check the rotation in the back of that pump. So you take this, easiest to take this cover off. Six little sheet metal screws. Have somebody look at the rotation. Bump the on-off switch. Just to make sure that from behind, looking at the fan or the shaft end of the pump motor, make sure that it's rotating clockwise and looking from behind. And that's in the manual too. We don't have hard copies of manuals, but we can shoot you over or we probably already posted online the soft copy for this manual. While I was just talking there a few seconds ago, you probably just heard the hot gas bypass solenoid valve click on. It slows down the rate of cooling a little bit. The whole idea is you want to minimize starts and stops on a compressor. Last thing you want is the compressor turning on and off, once a minute. They like to be running for a certain period of time. They like to be off for a certain period of time. So actually, because at this colder temperature and that hot gas just turned on, we might just sit there for a little while, which is good. Second lower light there. Let's see if that's legible. But focus? Oh, it's not focusing. The top one says compressor, the second one says capacity control. The bottom light is refrigerant fault. When that comes on, it doesn't always necessarily mean it's a refrigerant fault. It could be something else that creates the refrigerant fault. For example, if you didn't have enough flow going through the heat exchanger coming back to the chiller, that'll create a low flow and corresponding, because of the low heat transfer, a refrigerant fault. So, well, we're at 20. In our test environment right here is just a small loop at this temperature. It's probably just going to sit there at 20 degrees for a while, but it is behaving perfectly and as expected. This is Scott from KIG. Our website is kigsales.com. Thanks.